Section 2.3, we're going to talk about the remainder and factor theorems. So an opener there, long division, something you haven't done in a long time probably. So pause the video please, try that and come back when you're done. Okay, 3 goes into 410, so 3 goes into 4 once, multiply, subtract, 3 goes into 11 3 times, multiply, subtract, 3 goes into 20 6 times, we end up with 136 2/3. So why are we doing long division? Because we're going to do polynomial long division today, and it's pretty much the exact same as we just did. So you're going to start by setting up the denominator goes outside, the numerator goes inside. The only thing you got to be careful of is you want, from the degree down, you want every degree to be listed there. So x cubed, the next one is 2x squared, so that's good. But then we're missing an x to the first power. So you're going to put a 0x to the first power there, just as a filler, and then plus 5. It's not necessary, but it definitely helps. All right, then you're going to say, all right, x cubed divided by x squared. What is that? That is just x. Think about it. X cubed over x squared, you're left with x, right? So x cubed over x squared is x. I'm going to put that over the x here. They're going to multiply. X times x squared is x cubed. X times 2 is 2x. And you're going to subtract. The first term should cancel out every time. If it doesn't, you did something wrong. 2x squared minus nothing is 2x squared. 0x minus 2x is minus 2x. And then bring down the 5. And then just repeat that process. Now 2x squared divided by x squared, what's left? 2. 2 times x squared is 2x squared. 2 times 2 is 4. Subtract, the first term cancels out. Negative 2x minus nothing is negative 2x. 5 minus 4 is 1. You can try one more time, but negative 2x divided by x squared does not work. You cannot do, x squared does not go evenly into negative 2x. So that means you're done. And our final answer is right here. X plus 2 plus, this is your remainder. So I'm going to write it as 1 minus 2x instead of negative 2x plus 1 over your original denominator here. X squared plus 2. So go ahead and pause the video and try part B. Okay, setting up part B, hopefully you did 0x cubed, 0x, and 0. Dividing 5x to the fourth over x cubed, we're left with 5x. Multiplying, 5x times x squared is 5x cubed. 5x times 1 is 5x. First term cancels. 0x cubed minus 5x cubed is minus 5x cubed. Bring down the negative 2x squared. 0 minus 5x is negative 5x. And then 0 is just 0. Repeat that process. Negative 5x cubed divided by x cubed would be negative 5. Multiply. First terms cancel. Negative 2 minus negative 5 is positive 3x squared. Negative 5 minus 0 is minus 5x. And then minus negative 5, don't forget, so that's 0 minus negative 5, that's 5. We cannot keep going any further, so this is it. That's our answer. Our answer would be 5x minus 5 plus a remainder, which is 3x squared minus 5x plus 5 over our denominator, x cubed plus x squared plus 1. Okay, so same problem, written a little differently. X plus 6 goes into all that. No fillers needed because every degree is accounted for there. X cubed divided by x is x squared. Multiply. Subtract. X squared divided by x is x. Multiply. Subtract. Bring down to negative 12. And then one more time, negative 2x divided by x. Multiply. And subtract, and we get 0. So the question is, what does that result tell you? Well, let me ask you this. If I ask you what 8 divided by 4 is, you would say 2, and there's no remainder. Same thing here. So we would say 4 is a factor of 8, right? Because there's no remainder. Since the remainder here is 0, that means that x plus 6 is a factor of x cubed plus 7x squared plus 4x minus 12. So if I said to factor that cubic function, I would know that it's x plus 6 times something. We don't know what that something is yet, but we'll get there. But as long as we know it's something, that's a good start. Here's what the next problem is telling us to do. It says a factor completely using long division, knowing that x minus 4 is a factor. So the first thing we're going to do is we're going to use long division. No fillers needed. And I'm just going to run through this long division here. 3x cubed divided by x is 3x squared. Multiply. Subtract. And bring down the leftovers. Repeat that process. 7x squared divided by x. Multiply, subtract, we should get 2x, bring down the negative 8. 2x divided by x is 2. Multiply, subtract, and you better get 0 because it tells us this is a factor. So I know x minus 4 is a factor, all right? So now I know if I was to factor this, I would get x minus 4 times something. So the question now is, well, what is that something? That something is what is left over on top of our division bar here. So it's 3x squared plus 7x plus 2. So now we have to ask ourselves, can we continue to factor? Can we keep factoring this? And the answer is yes. 3x squared factors of 3x and x. And just by guessing and checking, we would get this, 3x plus 1 and x plus 2. So this is what's called completely factored form of the original equation. And now we could, if we wanted to, find the 3 zeros if that was a graph. Long division is lots of fun, obviously, but it's a little lengthy. So we can use something else called synthetic division if and only if we're dividing by a linear factor. Okay, x plus 6 is a line. X minus 3 is a line. If it's not linear, we cannot use syntactic division. So if it's not linear, you have to use long division. Let me repeat that. If we're not dividing by a line, we have to use long division. But since in A we are dividing by a line, we can use syntactic division. So what does syntactic division look like for you that don't remember? You take what would be the 0 of this, so that would be negative 6. And make a little L here. That's not really an L. Okay, then we copy down the coefficients. So 1, 7, 4, and negative 12. Again, make sure you fill in any blanks if there are any, but there aren't any here. So we don't need to do anything with that. Bring down the first number, so that's 1. And then it's basically multiply, add, multiply, add, multiply, add until you're done. So 1 times negative 6 is negative 6. Add those together, you get 1. 1 times negative 6 is negative 6. Add those together, you get negative 2. Negative 2 times negative 6 is 12. Add those together and you get 0. Some teachers, some students like to put a box at the end. That's your remainder. If the remainder is 0, that means it is a factor. So if we divided this out, we would get, since this is a cubic function, when you divide, you always lower the degree by 1. Okay, so our answer now is going to be a quadratic function. 1x squared plus 1x minus 2. All right, the second one, we're dividing by x minus 3. So that means the 0 would be 3. 2, negative 3. Notice how there's no cubic term here, right? So put a 0 in for the cubic. 5, negative 7, 2. Bring down the first, and then 2 times 3. Subtract or add. 3 times 3. Add. 9 times 3. Add. 32 times 3. Add. Let's see, what does that be? 89. And 89 times 3. I believe that is 287. And add. Now remainder here is 289. So if we divide 2x to the 5th polynomial divided by x minus 3, what we're left with is 2x to the 4th plus 3x to the 3rd plus 9x squared plus 32x plus 89 plus 289 over x minus 3, our remainder over our denominator. We can use syntactic division to evaluate as well. Sometimes it helps, sometimes it doesn't. For example, in this problem, if f was that function, if I wanted to find f of negative 2, what you can absolutely do is simply take negative 2 and substitute that in. And we would get 16 plus 3 times 4 plus 16 plus 12. And add that all up, you would get 56. Let's try it using synthetic substitution. So take negative 2, 1, 0 for the cube, 3, negative 8, 12. Bring down the 1, multiply and add, multiply and add, multiply and add, multiply and add. Hey, look what we get, 56. Both completely acceptable. Sometimes one's easier than the other, but if I asked you to find f of negative 2, I would not care which method you used. All right, next thing is the remainder theorem. We kind of already talked about this, but your remainder, if the remainder is 0, that means that it is a factor. If your remainder is anything but 0, it is not a factor. So what we're checking here is we're checking to see 1. So leading coefficients 1, 0 cubed negative 3, 0x to the first, and 1. Bring down, multiply, add, multiply, add, multiply, add, multiply, and add. So since we got anything besides 0, we know that that's not a factor. Okay, and what's the remainder? The remainder is negative 1. Go ahead and try part B. Go ahead and pause the video and try part B and see what we get. All right, part B, we're looking at negative 3, 2, 3, negative 8, and 3. Bring down, multiply, add, multiply, add, multiply, and add. So our remainder is 0. And what does that mean? That means that x plus 3 is a factor of that cubic function. That's what our next theorem is saying. The next theorem is saying is a polynomial has a factor if and only if the remainder is 0. Okay? So let's take a look at the next two. And we're just going to keep doing our synthetic division. Because this is linear, we can do synthetic. 2, negative 3, negative 10, and 3. And we're looking for an answer of 0. If it's anything but 0, our answer is no. 2, multiply, add, multiply, add, multiply. And we get our remainder is 0, which means yes, x minus 3 is a factor of that cubic function. Okay, and then part B, checking negative 2, 2, 4, negative 1. Don't forget the 0 filler for the x to the first power, and 9. Bring down, multiply and add, multiply and add, multiply and add, multiply and add, and we get 5. Anything but 0, which means this is no. X plus 2 is not a factor of that quartic function. So finally, the good stuff here. What are we using this for? Well, we're going to try to factor cubic or quartic or maybe even fifth power functions. So this says we know that's a factor of f. Let's factor it completely and find all zeros. Okay? So if x plus 2 is a factor, I know negative 2 will go into synthetic division properly. Bring it down, multiply and add, multiply and add, multiply and add. If you don't get 0, there's something wrong. Okay? But now we can rewrite f of x. How can I rewrite f of x? I can rewrite it as x plus 2. I got that from here. Times 2x squared minus 7x plus 3. So where am I getting that? From right here. 2x squared minus 7x plus 3. Now let's check and see if we can keep factoring this. 2x times x. And if we do some guessing and checking, we should get there. 2x minus 1 and x minus 3 will give us this. So our three answers in any particular order those are our zeros. All right, last one. This time we have a quartic function, but they give us 2 zeros, which is nice because we have to be able to get this down to a quadratic in order to factor it or use quadratic formula. So it doesn't matter which one you pick to start. Let's start with negative 4. 1, 3, 3, 21, negative 28. Again, we know negative 4 is a 0. We're told it's a 0. So if we don't get 0, something is wrong. We got 0. So that's good. Now, we also know 1 is a 0. Do not put 1 back into the original equation. Put 1 into this newly simplified synthetic equation here. Again, if we don't get 0, something is wrong. And I can't read my own writing, which is why this is not working. This is supposed to be a 1. Sorry about that. This is what happens when you can't write properly. So 1 times 1, add, multiply and add, multiply and add. Okay, but that's a good thing that I screwed myself up there because I knew the answer was supposed to be 0, and that's why I had to double check myself. So if you ever get into this situation where you have given zeros, make sure that you get 0 for your remainder. Okay, so now I need to factor f of x completely. So I know it's x plus 4. I know it's x minus 1. And then I know this. X squared plus 0x plus 7. That cannot factor. So that is it. That's our completely factored form. Okay? So if I find the other zeros, so I know my zeros are -4 and 1. To get my other zeros, I need to set x squared plus 7 equal to 0. X squared equals -7. Well, we know those are not real numbers, so it would be the square root of -7. Or if you remember from your Algebra 2 days, plus or minus I root 7. Let me write these down here. So x equals -4, 1, and then plus or minus I root 7. That's it for section 2.3. We'll begin 2.